looking at word problem number 4, dealing with air conditioning. We're going to try to answer this question without a graph. So question A says, what's the minimum temperature in the home? So remember, a minimum occurs if I have an xy axis and I have a sinusoidal function such as that. That's not this specific function, but I'm just using it to describe. The minimum will be the distance y is, so this x and y value, from the midline value. So the midline value we know is the d value. So if I can find the d value and the amplitude, I can find the minimum. So the amplitude is this number right here. So here goes. The d value, we know that. We know the d value is actually 20. It says it right there. It's written in front, but that's the same as putting plus 20 at the back of the equation. So we say d is 20. We know the a value as well. The a value, the number in front of cosine, is 1.5. So therefore, to get the minimum, we know that this min value for y is 1.5 units smaller than 20. So it's 20 minus 1.5. So that would be 18.5, and we're talking about degrees Celsius. That's the lowest temperature in this house. Okay, so that's part A. Part B, find the temperature 10 minutes after the air conditioning was turned on. Part B. 10 minutes after the air conditioning was turned on means that I need to substitute 10 in for x time. So we want to find t at 10. It equals 20 plus 1.5 cosine pi times 10 over 12. And that's it. Time at 10. So let's try and do this one algebraically and then check the answer on the calculator. Temperature at 10 equals 20 plus 1.5 cosine of 10/12 pi. 10/12 pi is 5/6 pi. And you'll recognize that as a nice unit circle value. So that becomes 20 plus 1.5. The cosine of 5 pi over 6 is a negative root 3 over 2. Equals 20 plus, let's get our calculators out and change this to a decimal. So that's 1.5 times root 3 divided by 2. So that's 20 plus a negative 1.3 rounded off. So that equals 18.7 degrees Celsius. So thinking back to the problem, find the temperature 10 minutes after the air conditioning was turned on. 10 minutes after the air conditioning was turned on, the temperature is 18.7 degrees Celsius. After 10 minutes. You should have a therefore statement for all these word problems. Okay, so we'll circle that. Your therefore statement can be abbreviated. So we'll do that one algebraically. On the test on Tuesday, you'll need to be able to do it algebraically for some that work out nice like this, whereas other ones that are more complex, you'll be allowed to use a calculator. Part C said, at what time after the air conditioning is turned on is the temperature at home 19 degrees Celsius? So what we have here, and I'm not going to draw this graph as I see it. I don't have it drawn yet. So we have a sinusoidal function that has a maximum temperature. 19 degrees is a temperature that the air conditioner will reach. So we're looking for this situation where we have a graph and a y value of 19 degrees Celsius. So if we take this equation, we know the temperature has to be a y value of 19 degrees Celsius. We're trying to find out at what time that occurs. So it's 20 plus 1.5, 20 plus 1.5, and the original question was cos pi x 12. Cos pi x 12. So we're going to solve this equation for x. Okay? And we're going to ask the calculator to do this for us. This would be an example of a calculator question. Okay. So let's enter this data the way we see it. I have to clear my screen from the work we did prior to. I'm going to enter the graph as y equals 20 plus 1.5 cosine. There's no c value, so I'm just going to enter it the way I see it. It's pi divided by 12. I should have put that x on top. So I'm going to retype that. Cos, insert an x right there. Okay, so it's pi x divided by 12. Now I need to close bracket. Okay. My window, we have a temperature as high as 18.7 degrees. Let's make the temperature, we can always come back, y maximum, something around 25. Let's leave the y minimum around -1. Let's change the x values. We have times like 20, 25, so I'm going to put in 20. And I'm going to take a look at the graph right now. We might have to change the window. Okay, so that's not so bad. I have a lot of values that lower that are not needed. So I'm going to change the window a little bit to see this graph. I'm going to change the x max to number like 35, so I can see more of what's going on there. And I don't need a y minimum of -1 really. I'm going to make the y minimum 10 degrees because our house is not going to get that cold or we'd be in trouble. There, now we get a good look at the graph. Okay, and we want to know at what time the temperature is 19. So if we go to y2 and draw a horizontal line at 19 degrees, so I go 19, graph, I'll now see that graph come along. And the time at which the temperature reaches 19 degrees will be the intersection points of that horizontal line with that periodic function. So I'll show you how to find one of those points. So we've done this before. You press second function, calculate, and this is a point of intersection. So go to number 5, enter. Take this cursor to the left of one of those points of intersection. I'm going to find this first one over here. So notice I'm on the left of that point now. I press enter once. Now I take this cursor on the other curve to the right of that point of intersection, somewhere around here. Press enter twice in a row. And I have that point of intersection as 15.2 time units where the degree of the house reaches 19. So I'm going to take that and include that in my solution. Okay, so I'm just going to read the question again. At what time, after the air conditioning is turned on, is the temperature in the home 19 degrees Celsius? So one time aspect where it reaches that temperature is 19 minutes after the air conditioner is turned on. So we'll write a therefore statement. And that's not the only answer. Notice that I could have come up with this value here. I found this value here, but this value here would work as well. So therefore, it takes 15.21 minutes after the air conditioner is turned on to reach a temperature of 19 degrees Celsius in the house. Okay, so I'll leave the solution up here so you can make your corrections accordingly.